Hello guys, welcome to another video. This video is going to be a tutorial rather than me doing a contest because I thought this is a really good problem. So it's going to be my first time teaching LeetCode problem on how to solve it and how to actually approach it. So now the interesting thing about this problem is LCP. I just find that it's such a good problem in a way. So let's get to it. So with LCP, we realizes that we can have a strategy that doesn't care about the majority of the LCP array. We're only looking for two things essentially. Let me just do let me just do draw. Right. So let's say that we have 5 characters. Let's make it 6. Anyway, so one thing to realize is that you can always begin the answer with A, the smallest, because the LCP array, it doesn't care about the numerical value of the elements as long as they're different. So that means we can essentially assign each index an ID, and then we can map all the indices with the same ID to a character. So therefore, anything that has the same character as the first one is going to be an A. So that's the start. So we start with A. Now all we do is we look at characters 2, 3, 4, 5, so on. We look at that in order. So now let's look at here. So why would this be A? What does LCP tell us? Well, basically, then you're looking at LCP of 0 and 1 to be greater than 0. Because that means these two are the same. Because they start with the same character, so therefore it has to be the same. And we know that since we start this with an A, then this has to be an A. And otherwise, so if this equals 0, then this has to be. Again, this is where the strategy really plays in. So then we can make this B. Basically, all we need is for character here to be different than a character here. So then we go to this. So let's say that this one's an A. So we examine the LCP table, then we find that the LCP of 0 and 2 is greater than 0. Now I notice I don't care about exactly the value of this LCP table. So far, just careful if it's greater than 0, because if it's greater than 0, then that means the first character, since the way we selected the table. So this is the first character of index 2, and this is first character of index 0. Then these have to be the same since the LCP is greater than 0. That means at least these are the same. We don't care about all the other characters so far. So we're just going to progressively determine a character. Now, if this was B, right? So let's say if this is B, then what would the LCP look like? Well, LCP02 would be 0, but then we have LCP of 1 and 2 is greater than 0. So basically, for every index, we look at the indices before it and check the LCP entries. Now, if this was a C, right? If this was a C, then this would be 0. So then since we run out of indices to check, then we know that this character has to be different from all these characters. So we can basically just go forward and construct it like this. Okay, but we're not done. We're not done. Because the LCP table turns out could be nonsense. If you look at the restrictions in the input, there's no restriction on LCP to be valid. Right? So we basically followed it in the best way possible. And we know that this is going to be correct Like if the LCP table is correct, then this is going to be correct. We only care about so far if the value is greater than 0 or it's equal to 0. But we can see with our strategy, then this must be the string. We followed the appropriate entries to the letter. That doesn't mean we need to abandon the other entries yet, because we're going to double check. So first, so just going to say construct string. So that's the first step. So now we're done with first step. Second, we need to double check. Remember, with this strategy, we only looked at subset of the LCP table. So now we need to double check. So it turns out it's actually quite easy to generate an LCP array. So this one we can just use DP. So now we can go to the code. So we start off with constructing the string. We set the first character to A. And here now I check all the indices before it. So if the LCP at this entry is greater than 0, then we know that's what character it has to be. Otherwise, I use the sentinel character, which is the $sign. So if it's a $sign, then we allocate new character. But if we run out of alphabet to allocate, then of course we fail. So now we pass this part. Now we have an answer, and now we recreate this LCP table. So yeah, this is just a standard transition. So we basically go backwards to construct the table, because like the key insight is that if you have LCP of I and J, it's equal to 5, right? Then that means the LCP of I plus 1, J plus 1 has to be equal to 4, right? Because then we just shifted the indices over by 1, so we have one more character equal. So we generate a new LCP table with this transition, and now we double check. So now if any element differs, then we just return. Now you might notice, since I'm using Python, I did choose to represent answer as an array of characters instead of a string, because one, Python strings are immutable, and two, concatenating strings. I do that. If I were to do that a bunch of times, I'd probably get timeout. So it's much easier and faster to create a list of characters, manipulate however you like, and join it to find a string at the end. So yeah, that's the problem. So I hope you guys enjoy.